Good morning everyone. Today I'm going to talk about central processing unit. So central processing unit or microprocessor or processor is the integral part of any computer, and today we are going to discuss about it. So let's start by seeing the history of the CPU and how they came into existence. So the way the history of the CPU is that in 1940s and 1950s the computers used to be the size of a whole room. They used to be a large mainframe computers. But in 1950s and 60s a revolution came, a revolution of discrete transistor CPUs, and they were size of a big table. And don't get me wrong, this is not the whole computer. This is just the CPU. But this on itself was a huge improvement from the mainframe computers, because rather than using vacuum tubes, these computers introduced the discrete transistors, which play a very important role when coming to the invention of the microprocessors. So let's talk about the first microprocessor, Intel 4004. This was considered as the marvel of engineering and design. To this date, this is considered as mankind's one of the most important invention, if not the most important. So how did Intel 4004 came into existence? The way it was invented was that in 1969, Nippon Calculating Machines approached Intel to build 12 custom chips for its new Busicom printing calculator. Intel's engineers suggested a family of only 4 chips, including one that could be programmed for a variety of products. And this was the solution proposed by Intel. Intel designed a set of 4 chips known as MCS-14. It included a central processing unit chip, the 4004, as well as a supporting read-only memory chip for custom application programs, a random access memory chip for processing data, as well as shift register chip for input and output port. You can see this is very much like architecture of a modern computer. You have a CPU, a ROM which is hard disk, a RAM, and an input and output device which are usually keyboard and mouse. So you can see how impressive this solution by Intel was. But the most impressive thing about the solution was not this. The most impressive thing was Intel 4004, which, when the company realized its potential, they purchased the rights from Nippon Calculating Machines Corporations and launched Intel 4004 processor as its chipset. And it was advertised as an era of new integrated electronics, and they indeed were very right about it. So now we know about how the CPUs came into existence. What role do the CPUs play? CPUs are considered as the brain of the computer. This we have been learning from the age of like 10 or 11, when the computers was first introduced as a subject, that CPU is the brain of the computer, and this in fact is very right in a basic sense. And then CPU performs all type of data processing operations. It stores data, immediate results, and instructions, which are known as programs, and it also controls operations of all part of the computer. So these are some pretty significant roles the CPU plays. But the more interesting thing about it is, how does the CPU do this? And that we will understand by understanding the working of the CPU. So the working of the CPU is that we'll understand the working of the CPU in 3 different levels, and with each level the complexity will increase, but so will our understanding of the central processing unit. So let's start slow and easy with level 1. So you can see in this diagram there are 2 important things. There is a processor and a RAM. RAM has 2 data sets, a data and address. and CPU has two buses, address bus and data bus. So the way the CPU reads the data from the RAM is that it first turns on the address bus, which takes the address from the RAM, and CPU cannot do anything until the CPU allows the RAM by enabling the enable wire and sending that data through the data wire back to the CPU. And this is how the CPU reads from the RAM. But you might be wondering, this is the process for only reading. How does the CPU write its result on the RAM? And you will be very right, because the way it writes is completely different. The way it writes is that first it turns on the address bus, which then tells the address to which the data is supposed to go. Then it gives the data which is supposed to go in correspondence with the address bus, but the data cannot be written until the CPU turns on the set wire, which enables the address and the data bus to set that data. So this was how CPUs worked on a very basic level. As you can see, this was a very basic understanding, and we understood how does the CPU works in conjunction with the RAM. But let's now take RAM out of the picture and open the lid of the CPU and see how it works. So if you open the lid of the CPU, you can see there are two units, a control unit and an arithmetic logic unit. You can see the data is coming from the RAM and the instructions are then going to the control unit, which depending on the type of the operation is giving it to the arithmetic logic unit, which is performing its arithmetic logic and giving the output. You can see the control unit is more like the brain, so it is more like an executive, more like an manager, and arithmetic logic unit is the one that actually does the work, so it is more like a worker. These are the two basic units of the CPU, and we'll be understanding them in more detail in level 3, but here we can understand the basic difference between them. So now let's go to level 3. We'll understand how does the CPU work. But before we do that, the first thing we have to understand is that in this level we'll be going into a reverse order. So the first thing we'll be understanding is, we'll be understanding it in parts. The first thing we'll be understanding is when the data is processed by the ALU, how does it goes to the journal register. So you can see here in this diagram there are a lot of wires, don't get confused by them. The thing which is happening is somewhat basic and understandable. The thing that is happening is that arithmetic logic unit has given the data into a temporary register, which is represented in green here, and then control unit is turning on the enable wire, which is enabling that temporary register to send that data to the general purpose register, which is represented in red color, and then control unit is turning on the set wire of that temporary general register, which is allowing the data to be stored there. This is how control unit, how the data from the ALU goes to the register. As I was saying, we'll going in a reverse order. How does the data goes from the control unit to the ALU? So remember I said that the 4 registers on the top are general purpose registers, and they are called general purpose registers for a reason. And that reason is that they can be used to store as well as send data to ALU. Here you can see in green represented a general purpose register has an enable wire turned, which means this data is going to the input of the arithmetic logic unit, which is going to do its which is going to compute its arithmetic logic on the data via the address bus. And as you can see in this, the data is going through that register from to the input A, which is then going to arithmetic logic unit, and then it is going, then the arithmetic logic unit is doing its task. This is the how the data from control unit goes to the arithmetic logic unit. Now let's see how does the data goes from the CPU back to the RAM. You can see here the represented in green, the instruction address has its enable wire turned, which means that instruction address is sending its instructions that at which address the data is to be stored. But this address is not going straight to the RAM. This is going to a memory address register. Not only the address, but all the general purpose registers are also turned red, which means the data as well as the address is both are going to the memory address, which then outputs this straight to the RAM. And this is how CPUs work on a level 3. So this was my presentation. Thank you very much for watching. These are all the acknowledgements I used for making this presentation. Thank you very much.